So hi, it's good to see everyone to this chapter on function, and function is quite important apparently in R, and they are quite tricky, and I do not think like I understand fully them. So hopefully we will make progress on it. The learning objective are to make function in R. Obviously, you should probably know a bit about it, but the book have plenty of gotcha, and chapters were like stuff that I was not aware. And we're going to learn what's are the part of a function, a bit classic, and see how calling function inside of the function work. How to make a simple function in R. Function have three components: the formal, which define the core or the body of how the function is defined. It includes the body, which is like exactly what happens, and formal is like the argument, and environment is where the function is located. Small quick example, I shortened that a bit before the previous version, but if you want the dataset, it's clickable. You can click on it. It's CSV in I think Tidy Tuesday. So it has like, I should have maybe convert that to Penguin and do Penguin spaces, but it's fairly similar. So this simple function giving an average of, I have no idea exactly how you measure like the mean of total cup point. I don't know that's some value of coffee by space. I don't know if it's spaces or subspaces, category of cafe, I will say. And so when you call that function, it's used actually a trick because coffee rating is loaded probably in the global environment when you download the function, when you download the set. And then it's do a bunch of stuff to return the average. If we look at the format of it, this is just the spaces. Funnily, we have this weird dot spaces. I'm kind of curious why it decided to print that way. And then you have the bodies, which is like the function, what's the function does. It has like, if you look at it, I should have correct that because this was the previous and I didn't update like no, this is the correct update. This is all like the body's return after calling it. So it's slightly different than the pipe. The pipe are changed, I guess. And the environment, it's a function defined in the global environment. So it's just here. Function use attributes, and that didn't know, and I wanted to correct that, but I have not done it. When you call attribute with source ref, it should print the function, but it should print the function with let me correct that.
It's possible that that's a rendering thing.
It's I ask
removing it.
I investigate that, and it's basically
Okay.
like, yeah, you need to so it's returned like, unless if I do the body of my function, it's hide the comments, while if you ask for the source ref, it's gonna return everything, including my comment here, which is useful if you have code correctly commented. While body probably I don't know how the function body works, but this side the comments are not returned. But to answer the John question, Gabor, I pronounce probably his name terribly, Gabor, replies that if we keep the source generated from the markdown document, we should have not null pointed. The return should not be null. So it should have correctly. But I didn't wanted to do that for all the, maybe there's a quarter chunk. I don't want to specify that for all the slide, so I didn't touch it.
Yeah. Yeah, we'll take a look after whether we just put a note in the slide or deal with it one way or another. We'll sort it out.
But this is quite useful if you are inspecting function. I didn't know about that. Okay,
I
so
forget about that.
Oh. Yeah. So basically, like you have core function in R. Sum is a good example, and you can see like if you print sum, just type sum, it's an object, and then it's gonna be printed. It's returned like this primitive sum. And you have basically two types of primitive that you can access with the type of. And you see like sum is a primitive of type built-in. And you have special. I do not have any example of special in my mind. If you have some, feel free to share in the chats maybe. Nope. And funnily, like this core function have components null when you ask for them. So what does that mean? Like if I do a body of sum, oops, sorry. See, it's the return is null because it probably like the function is probably implemented in C, I don't know. And body, I have no way of returning it. In fact, if we ask body, we can probably see why it decides to, oh, it's also an internal function. We don't know exactly why. Okay, question about that? Remark? No? I go? Okay. Anonymous function. You don't need to name a function to make it works. And this is a simple example with lapply, where like you select mpg and seal from empty cars, and you ask the length of unique of them. And it's return a list, which the first one is mpg with one element, and the second element of the list is seal with three. Anonymous functions are used a lot in all the higher order function, as being like the lapply higher order function is functions that take function as an argument. So here, this is like this function. Right now, R has another syntaxes for anonymous function. I'm not a huge fan of it, but feel free to use it. It's this syntax, if I'm correct, something like that. But I don't use it much. Something like that, no? Will work. Oh no, it's not this bracket, it's the other one. This is this one? I never know. Remember which one it is. Yes, this is this one. I think for me, I prefer when for having function the X. I think it's more readable, but that's totally it's a matter of taste. And this is exactly the same. Like instead of having it defined here, we defined here. Question regarding to that? Seems I can go. Cool. Obviously, in the formal of the functions, a lot is happening that I not fully understand, but I understand more with these chapters. So if you create like args is gonna return just the coffee list of spaces, and I'm passing it as a list. It's returned probably a vector that I convert as a list. And if you pass that list, because do call take list, as an argument, you can generate the, oh, it's the first one, not the first. Probably Arabica. Arabica is probably the first. And it's quite handy to do that. So you can use it to pass multiple arguments into a do call. So if you have a function that takes a lot of arguments, instead of typing all the arguments, you can assign all this argument to an M object and pass that. And it's used a lot with lapply. If you do classic split apply logic instead of using for. And so I try to pass without using do call my arguments, and it's not working, and then I remember it. function composition. I tried to shorten that slide quite a bit. All these three ways of writing the function are the same. So except like the first line, like you need to generate X, and then we're gonna use X to do a bunch of stuff. This way is like a nested function call or function composition. Like you define first square, you then define deviation, and then if you want the square root, you can define that by using like square, mean, and this is deviation is defined above, square is defined here, mean is a built-in function, and square root is also a built-in function. And you can also do it that way. And this is like the intermediate result, and everything is sent to the same out object, which can be dangerous. Or you can use pipe, which is basically fairly close.
So Martin has a question in the chat about the base pipe versus Magritter pipe. There is a difference. It's tiny, but there is a difference. So the base pipe happens like it's special. It happens before the code is, what's the word? It's before it is
evaluated.
It's interpreted, but not before it's executed. So it's as if you wrote it without a pipe when you write it with the base pipe. Like R creates the thing to execute. That's exactly the same as if you didn't use a pipe. Whereas the Magritter pipe actually is a function that gets called and can have weird side effects in some certain cases. The other main thing is that Magritter pipe uses dot as a placeholder, and the base pipe uses an underscore as a placeholder, with slightly different rules about what you can placehold. And I think there are some special. God, there's something else that Magritter. It might have just been the placeholder.
I think on the placeholder you can just choose a scalar in the. I mean, just one object, while the Magritte Pi can take multiple objects in their placeholders.
Oh, like reusing it. Oh, and yeah, that you can put it in place of, like you can put it somewhere else in the call where it's an unnamed parameter versus Magritter. It doesn't like Magritter can be unnamed. The base pipe core is named. It's really like esoteric things that you can always write around. And the biggest bonus is that it doesn't require a package, and it isn't actually doing a function call. So it's like exactly equivalent to writing out the code, versus the Magritter pipe was always kind of almost a hack, like a really good hack, but a hack.
So in some way, the native pipe is easier to debug.
Yeah.
Magritter also lets you specify the function by name instead of including a function call. And maybe that's bad style, but I got used to it. So then when base pipe came out, I kept on forgetting. I still to this day keep forgetting to put the parens if I'm calling a function with just the one forwarded argument.
But in general, would you recommend to using the base R pipe? Like it's a best practice.
Almost always, yeah. So
almost always, okay.
The one asterisk is if there's any reason that someone you're working with is using technically prior to R 4.1, like 4.0, I think is when they actually introduced it, but then they expanded it in 4.1.
Okay.
So it like Tidyverse is starting. I think they are officially dropping support for anything that can't use the base pipe. It's been long enough that they don't support those old versions of R anymore, and they have a really wide window. So probably you're fine if you have some server somewhere that you're working with that can't upgrade past R 3.5 or something. You'll probably run into other issues anyway. But that's the only asterisk in my mind.
Nice. Thank you.
Thanks for Thanks also for sharing the link. I should like you still have a lot of weird corporate environment that use Windows and they are still on 3.6 R version of it for some reason. So if you
don't blame
package,
Windows for that.
I'm
That's
blaming
weird
Windows for
corporate
that.
thing.
Yeah, because like they are on Windows because they were corporate, like everything is connected. I know you are Windows
I'm on
dependent,
Windows.
John. So
I'm
you are
on-
part of the
Yep.
team that's like to put everything into like the one file hierarchy. Well, in Linux we prefer to spread the file everywhere. Anyway, yes. So like yeah, this is like the if you want your code to be run by 3.6, you should avoid pipe. But like if you are writing function in some way, I mean, I guess people like have a lot of opinion on that. I don't know. I will avoid the pipe and try to make like this code can be written very similarly. Like for example, this one, like you can, if you want something like, see, I can do sqrt, go on, oops, sorry. This is the default, then min, and then square. If you want to have something like very nested, like more readable, this is always an option. Deviation, you lost it like here, and then I need to lost all my parentheses, and I can also do that at the end. So this is another option like that you can do. I miss one apparently, see. But yeah, that's more or less. I agree with John. Like soon,
that was very funny. That was very funny to me that you missed the close parenthesis because like that's why
you always
that's the argument for the pipe.
I understand the argument, but like this is another option that I offer you. But I agree with John. Like at some points, like when it's too deeply nested, you lost. Well, the pipe obviously is easier to maintain.
Like I am making fun of it, but I still tend to write everything as nested parentheses if it's for like a package, because I got in the habit of, oh, I don't want to add the magritter dependency if I don't need to. But there's really like it's not bad anymore. Like there's no dependency that you're adding.
And if you are
a lot of times it's more readable. Like, that's the whole point of it is especially once you learn that the pipe is pronounced and then, and if you do that when you're reading your code, the pipe is super, super readable. Sorry,
but
I love the chat.
If I do quick complex computation, I will definitely print an out and just use print to test my result also, or assert something like does like how many columns do I have? Is the column number correct or stuff like that? So intermediate results are also useful sometimes, but I will not lend all of them out. I will just use Bill and Bob, which is worse. Or Alice. More about function inside. So this is an important part. We're gonna discuss a lot lexical scoping and the role of it. We're gonna see the name masking ID, the function versus variable, which I was not that aware inside of the formal. What it's meant by every function is a fresh start. This should be obvious, but maybe it's not. And the dynamic lookup on when the lexical scoping happens. Name masking, you will have to, so I shortcut, to make it in one slide, I used the semicolon to split it to make it, but I understand like it make it a bit less readable. So it serves for more polluted global environments. That's what. So if you have Bob, that's take one, and Alice, that's take two. If you have like the functions that just take Bob as test and Alice as bacon, and I'm returning a combination of both, it's return test and bacon, because what's inside of the function have priority of what's outside of the function. And this is what G03 does. So since I did not setting up inside of the body of my function Alice, it take Alice from the global environment and it converts everything as a characters. And name masking is super useful. Here I use bug analysis, but if you start using plenty of X, Y, and if you mess up your code using also iterators with Y, you will protect yourself a lot. So using even random function, like I remember one of the first stuff I told some of my coworkers, even if you have a big script, just working with a function without argument and collecting will clean a lot your code, because then you will have less mess around it. It also applies for function name, obviously. I think name masking, everyone know that and use it well now. I think this is the easiest one of the crew. Function versus variable. I use the use function. Do not be too smart. Do not try that. So yeah, I use the example of Hadley because I have not been able to generate another example. But here you have G09, which is defined in a global environment as a function. And inside of the function, we have another object, which is a scalar that's defined as, that's linked to 10. And then when you call G09 with the formal of G09, you are calling the function 09, defining a global environment with the G09 is the G09 defined at line 3, which return the expected value of 110. So I think advice is not doing that. I do not see where you should do that, but maybe it exists. I don't know. But yeah, avoid doing it. But I didn't know
So that, like you don't even have to have it in a function environment. Like as long as you don't use the parentheses, it will check like you can have both. You can have a function and a non-function defined with the same name. And again, the one thing that matter or that it's useful for, not even useful, but like if you use df for the name of a data frame, and there's also a function df, you can actually use both, and you're not breaking anything other than the brain of anyone trying to read your code. So,
which is important. And
yeah.
And you may be assigned df another time and mess up your life.
Yes.
This example works because G09 function is created in the global environment and the variable is created in the function environment. This is why it works, or are I missing something?
It's working because it will be recursive also if it's called the same function all the time. You will not be able to break it also. So it's working. It's working because like if G09 is calling G09, that's calling G09, that's calling G09, it will break also. So I think it's also like a language decision, but this is also to help you. And the order is like, yeah. This one is great. I added 2 print statements on this one about the fresh start. When you call a function, it does not update what's inside of the function. The example is like A here, the letters. If it does not exist, it assign 1. And if it exists, it's add +1. And I had like I'm here because like we are doing that. And dead branch because we never going into that unless we have A in our global environment. And you can run that function all you want, you always get 1, and you're never gonna go into the dead branch unless you have A defined in your global environment. But I think this one is the easy one here. So dynamic scoping. So when R look for the value when the function is run, it does not run the function. So here I should have like so this is a Quarto stuff. It's like here this G12 sorry is returned here, and because like here before recalling G12 I assign a new X and I got 21. This one's pretty easy, but it can be hard. I didn't know about cut tool. I don't know if some people use it. You can find the global, what's the function use, which here it's funny because it's mentioned the plus, which is the function, a specific kind of an operator that's a specific kind of function. And it's really, it's because like it should be funny to look at the traceback how far the plus function is. I don't know. But if you run that, you assign an empty environment to that function, obviously you can't find anymore the plus function. And I was curious about even if in an empty environment, that means like the empty environment does not have parents. But we're gonna see that later in the chapters. I will have the assume empty environment have the global environment as parents, but I don't know exactly. I didn't check that. So it's R cannot find the plus function because it's not linked to any kind of environment where I can find it. I don't know. Lazy evaluation. Wow, this one was so function arguments are only evaluated when accessed. The example that Hadley give is like if you have like a function with a stop inside of the argument and you never call the arguments inside of the formal and you never call anything inside of the formal, it's never gonna stop it. Yeah, and that's also mean like if you have some arguments that are never called, you're not gonna see it. So this is also, I guess, a strong argument for testing your arguments. There's a lot of argument in my sentences. So you be sure, like, because like if the function is not run, I mean, if the argument is not called, you don't know if it works. So we'll have no error.
You can also,
yeah,
you can use that, the laziness. I can't think of a real example right now, but you could have like the default argument is an error message, for example, or that's not a good one. I don't know. There are cases where you can like pass in something that it's going to cause, a slow operation. I guess, yeah, Shiny kind of uses this, that if nothing ever uses that argument, it never actually gets evaluated. And so who cares that it's a slow operation? But if you go down, if something else is set that causes it to be useful, then it will do the slow operation. So, it's easier when they're like, I have definitely had concrete cases where this was really nice, but I can't think of a useful example right now.
That's the argument Hadley give, if I remember correctly. If you have like an argument that generates a huge simulation, you don't want the huge simulation to be run when it's run all the time. So if it does not need it, it's not gonna be able to. I mean, it's not gonna run it. I think it mentioned also like some other places. So maybe I will go back to that. Promise. So promise, we're gonna see that at chapter 20. I'm kind of curious because I found multiple definitions when I was trying to find them. One of them is related to the future verse, which is like, here I linked to the original papers. And if you look at promise here, see, I have already searched for it. I think I have a good example here, which is like, it uses a specific kind of operator here. So you have an expression, typically like, let's say x plus 1 or square root the v. And it has a specific operators where it's not going to run until the operator expression v is called. So when you do square root of v, at that point, v is called, and then we're going to call the expression. I mean, so this is one way of defining a promise. And we're probably gonna see that later. So it's here that expression is called only when v is called.
Yeah. So here, there's
in a specific environment. I should have said that. Yes. Yeah. Sorry. Go.
Yeah. The promises book, or sorry, the promises package calls out of actually. Unfortunately, promises are used to mean two completely different things in R and programming in general. I'm trying to pull it up right now. Sorry.
I have it here also. Like you mentioned.
Oh, do you? Okay, yeah.
Yeah. Ups. Okay, yeah. If you need it, John, I have like linked it. Yeah.
Yeah, I've got so in the chat here. Yeah, so this is from one of their articles that are you able to?
Does not like me to link your. It does not like your link.
Is it too long? Maybe.
I don't know. I'm gonna copy open in the browser and see if it works.
Yeah, and
No.
if not, just go to Article 2. Are you using? Yeah, I think those links actually only work
this
in
one?
Chrome. But yeah, if you go to Article 2 and then scroll down a little bit, it says, "Oh, yeah, I know what promises are from." Yeah, there it is. Scroll down where it says the NSC chapter. Stop moving. Go up a little bit. I can't tell anymore. There.
Yeah.
So yeah, the promises package, which is about like async programming, and it's a different, like the word promise means a different thing. So just to throw that monkey wrench in the works of like there, I think probably more often, actually definitely more often, a promise is used in the async programming world with a certain meaning, but in this book, it has a different meaning.
And we're gonna see it, but it seems quite important. So I wanted, and that's why I linked to the 2 version of it.
Yeah.
Which is fine, just need to know. In which context you need the environment of the definition to know what it does. Any question regarding that? So by the way, like I have not time to read this whole article, but it seems very good. So it has a lot of stuff that I'm curious to. So, but I didn't have time to read it. Oh, this one was tricky. So default arguments, like the idea is like you can even use a value defined and the formal of the function by other arguments inside of that formal. I would never have done that, but apparently it's possible, and I do not recommend it. The example is like you have like function Bob, let's say Bob, and it's like X, Y, Z, and X is defined by the value of Y, and that is defined by the value of X plus Y, and even from value that's defined inside of the body of the function A plus B. So I don't want to put it because it's not recommended by Henley. I guess it's powerful because then like you can build, let's say like some geometry stuff I could think of, like, well, you have like some value that need another value that derive from the other one. But I think at that point, why not using the body of the function? But I don't know.
So, I mean, I think this would count where you might have a default where the title, like I have a Shiny app where the default title on the window is taken from a data frame that is a different argument if it is there. But if it's not, number one, it takes a function and applies it to figure out what the title will be. But also, I don't want to force you to use that, and so you can override it. And so that's why it's an argument that relies on another argument. I actually like, I'm skeptical of Hadley not recommending this because it's everywhere in the tidyverse.
It's not recommended by Hadley. I assure you.
It's done by Hadley, so.
What do I want to say about that? I mean, my instinct will be like, if you have some logic inside of a formal of a function, shouldn't that be a function?
I want to look at.
So we can go for it.
The wording. Where are we? So.
Book.
Because like that's how Tibble works. That you can have function. Argument to column B is column A squared. And you're doing that
default
as arguments. So in defaults, use what technique? In terms of variables defined, blah, blah, blah. I want to see what that said.
But I don't recommend it. It makes the code harder to understand to predict what will be returned. You need to be exact.
Variables defined later in the function. Oh, later.
Yeah. Especially, I think what it is like, especially that.
Right.
this part. Like the z is defined, it's used argument that you can change in the formal of the function, but they're also defined inside of the body of the function. I mean, they are defined, they are not defined, they are here. I think this is that it precisely dislike. I think it's totally fine with that, my understanding, but this is hard to resonate to have logic on it.
Oh, geez. Okay. Yeah, that you're defining it in terms of things that are like internal to the function.
Yeah.
With that z.
To the body.
Yeah. Yeah. That definitely not.
And he
give
a very good example. He gave a very good example.
The example
here.
of why there, he does all the time. So
yeah. No, this one I think is fine.
Yeah.
These two, like x and y,
okay.
and y defined by x. But z with a plus b defined either by and this is a very funny example that he gave also, like with listing ls probably defined where it's the call of lx is gonna return differently giving where you execute it. So if you execute it as x inside of the body, or you execute it differently inside of the formal. Yep, that was like, my head was like, oh, why? I mean, not why, but okay. But I didn't want to advertise that, so I didn't use it. Missing arguments. Missing check if an argument is missing. It's returned true or false, depending of the argument. And then you can branch according to it. And I write do not be like sample, because sample use, sample, I think the main critique of sample is not anymore a function, it's an API. So giving the argument you feel you're gonna produce totally different kind of sampling. And it should probably have been, it should have been multiple function instead of one that's branched differently according to what kind of argument you provide. And it used a lot of missing. And Hadley advocate for using like this kind of weird operators that I never remember. Where is it? Where did I put it? I don't remember. Oh, here. Instead, he advocate for, where is that operators? Yeah, the coalesce. I'm gonna call it coalesce because I think it's switched from the one side to another side depending on it's the coalesce like in SQL. And that's it. That's how you write it. But if you never have used sample in your life, you do not know. But if you have sample, you probably tripped on x and size and fell at it. It's happened to me every time I use that function. I do an error. I use it badly. Okay. Dot as no as, if I'm correct, as ellipsis. I didn't know there was a name Hadley use. Here it's a very simple argument. You have a function that generates a list, and if you wrap that function into the previous function, it's just gonna add the list. It's passing the x, by the way. And this logic of ellipsis, passing everything to another function, is used a lot with higher order function. So the lapply family or the radius one. I think we're gonna see that later also, because like the evaluation of this that is kind of complicated. I use them also a lot in function factories, especially with writing to database. Exiting a function. An exit can be implicit. It's returned the last. I think it's the last. Will you call that a statement? I never know. The last line executed. Or it can be explicit using returns, the function returns. I kind of like being explicit even in stupid function, because it's making clear what it's return. So I favorite that. I don't know what are your policy on that. Maybe on simple function where it's obvious you don't need to write return, but on more complicated, I tend to be explicit.
I also tend to be explicit, and the tidyverse team does not, like, pretty much ever. And so that's something where I am different from their style for sure.
Yeah, it's also like when you switch language, for example, I think Python use return, not with parentheses, because Python is no comments. And that's make it easier also like to switch for one code to another code. And one type, no, not what kind, one programming language to another programming language. Invisibility, obviously, like the assign function return invisibly. Like if I do nothing is returned, so it's returned invisibly. And if I wrap that, I'm curious, I'm gonna have like the linked value from the name. And the the parentheses, I'm never think too much about what they do. Does they remove the invisibility? Does they decide to print something? But they are quite useful if you want to quickly check what you are returning. And in the shell, it's easy, like Control A and you add the parentheses, and Control O and you add Control CTR. I never know. And you can add the parentheses. Not that hard to use parentheses, folks. Stop is using to throw an error, and the first argument, if I'm correct, are the error message. You can also, when you exit the function, use exit handlers. This is something that I used a lot. I think we're gonna see them later, but on exit, take two arguments. I think the first argument is an expression that should be run when the function exits. And the second one, I think it's add equal true, because if you call multiple time on exit, I think it's the last one that is called. John, did you remember that? I said that from my head. So let's
I'm pretty sure you are right as well, but I'm not 100% certain.
Let's give an example. Take. Sadly today. Function.
Yeah, it's if add is false, which is the default. It only does the most recent one that was called.
On exits. Oh, okay. So I don't need to test it. Yes. So it's super efficient and it's super good. I use it all the time to restore a previous state. And one of the states that I like to restore is disconnected from database. So you don't, you are not open all the time and you don't suck up the database connection. Function form. So R has a lot of function form. The classic one is we can read at that code. I like it also. So I guess the previous people liked it also. So everything that exists is an object. Okay. And everything that happens is a function call from one of the R creators. So that's basically every computing. Now you just need to add the environment and we are good. Prefix, the prefix one is the one we all know. The infix is the plus. So the operators happen inside of the expression. And the replacement one, it's assign a name to or value to a name. And we have the special one, which is like, I'm moving that.
Olivier, I think you're on mute.
Oops, sorry. So what can I check for? Like that? Yeah, special. If not, like, I guess R was watching me to generate some loop here. So, and I provide him a parenthesis. So it was like, what happens, dude? I don't know why you are doing that. So yes, we have an example of a special. I'm kind of curious the type of this one. It's a special also, yeah. And I think that's it for me. I do not believe I managed to convey all of these chapters. And then after there's a case study that I didn't look. And it's probably from the previous edition of the book, John. So I didn't go too much into it. So does any one of you have a question, remark?
Yeah, I didn't have a chance to dig in, but I was going to go in and just delete. Don't be afraid to delete. It's on GitHub. If you're not going to use it, delete it.
I was like, yeah, I didn't wanted to delete it without like, I don't know. It's interesting, so but it's very old because it uses reshape too.
Right, and
probably,
therefore it's adding a dependency that we really don't need in the book.
yeah, and melt. So I don't know. It's using the old package. Question, remark, people. Stop sharing.
In the chapter when he was talking about on exit, and he said, this example shows how the on exit is called even if the function has an error in it. In the example, it doesn't, at least when I look at the web page for the book, doesn't actually show the message happening. But
No.
Yeah, that's an error.
But I ran the code. I was like, what? And because I was like, did R change? But no.
That's funny.
Where is it? Exit on right here. Is it this one?
Yeah,
So you see, you don't see the goodbye at the very end, but it happens after the error message.
Let's try it and see if we can trace it. So, did you read my? I didn't check. Let's see. I'm lost in all these numbers and copy. Should have typed it.
Wait. There's one before.
It's work.
Yeah. So it works,
Yeah.
but it doesn't, like, the book doesn't present it correctly.
I think this is the same issue that we had with the attribute source.
Maybe. But yeah, it's a like rendering issue, not the code issue. Because it is worth checking.
Oh, it said already.
R has changed.
Yeah.
And so, sometimes it is that the book is no longer correct about it. And then sometimes it's like this, where it just renders weird.
Yeah. I also had a completely unrelated question about ... I've seen some functions, and I can't think of any examples off the top of my head, where the first argument is ... and it'll be a list of expressions or something like that. But then there are additional named arguments afterwards, and I wonder how you handle those in a function body, because based on my reading, if you call list ... that's great if all of the the var args are named, but if they're not named, if they're just expressions, I don't know how you get to them. And like ... .2 doesn't necessarily work if you don't know how many there are. So I still don't know how to program around, like, that's something that I've made very, very sparing use of in my code, just because it's kind of funky.
I mean, you can do, you can still capture them in a list and do list 1, list 2. If the order matters, then don't do it with, give it a named argument.
Right. So list ...
But
you assign list ... to something, and then now you have a list that has all of your
Yeah, you can do, and then we will get into, I think, some of our Lang has fancy dot handling, like it has a list to function that does a little bit more to help you with that. But even you can just do, like, it's very common to see this
What's the
in
default
code.
hello quote?
And you know, to save yourself 5 seconds when talking about it, everyone just says dots. You don't have to always say dot dot dot.
Okay.
So
just say dots.
Yeah, pass the dots. You can pass the dots. I guess often the dots is what people will say out loud. Anyway, but yeah, it's super useful. Oh, you can also there's dot dot length is a function that will tell you how many dots there are. So if like you have to iterate over the dots, you can use that, or you can just do for you know, for whatever in dots. But yeah, dots are really useful because it lets you do things, you know, like building a Tibble. You know, Tibble wouldn't work without dots and things like that. And then also just if you want to, if you're doing like a pass through to another function, and want to be able to support whatever arguments it might add or whatever, you just pass dots onto that function, and then people can use your pass through without it breaking anything.
Why is it wrong?
And dot 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 length is a function that takes no arguments.
Yes.
Cool. Thanks, R.
Oops. Because that it's telling you the length of dot 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 within this function. So
why is it like that? I'm trying to run the Quarto file, see if it's a Quarto issue. But I don't know.
oh, there's a special thing in the help for dot 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 length and dot 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 names that you can use those to get, you know, the length of the names without evaluating the dots, which I know I have had to work around before, where I want to just pass it through. I don't want to interfere. I need to see if I can find where or what that is tickling in my brain, because I swear I just had to do something with that.
Yeah, and I failed reproducing it in small Quarto example to see, but like the G06, like this were the 06 message. Anyway. That was good. We are on time. I didn't I was like not expected to finish on time.
Yeah.
I mean, except if other
Big
people
chapter
have
for
questions.
sure.
Yes. I mean, environment is big also, sorry. About it. I think it's Josh who inherited it. But yeah, it's a big chapter too, if I remember correctly. So for those who go to POSIT conf, enjoy it. For the rest of us, I'm gonna retweet you or boost you and spread the love of our in my social networks.
Yeah, I will probably get noisy on Blue Sky before long.
I don't know exactly how Blue Sky works, but if it's bridged to Mastodon, I will share it still.
We'll see.
We'll see if you manage that, John. Come on.
Yeah.
In too hard time, it's better to have a European platform, I feel. I will stop my comment here. Bye, everyone. Did you type
All right. I did not.
Sorry. Where's the chat?
Go for it.
Chat. Where are you, chat?
Thank you very much.
There we go.
Thanks.